right, so P3, we're going to talk about polynomials and special products. So here are some examples of polynomials. The degree is the largest degree that you have. We write it in standard form by putting the largest degree first and then decreasing the degree from here. So our largest degree that we have in A is x to the 7th power. So that would come first. Then we have plus 4x squared plus 3x minus 2. So this would be standard form. Our degree is 7, because that's the biggest degree. And then the leading coefficient is the number that's out front of your largest degree. So our leading coefficient would be -5. For B standard form, we'd have to put -9x squared first, because that's our biggest degree. Degree would be 2. Leading coefficient is -9. And C, it's just a constant, so the degree is 0, because there is no x, and then the leading coefficient is 8. Sometimes you might have x and y's that are being multiplied, so on the next page, here we have x to the 3rd power and y to the 6th power. Our degree here would be the sum of these two exponents. So we have the 3rd power and the 6th power. Our degree would be 9. In the next one, remember when there's no degree written, it's like it's a 1. So the degree for the second one would be 2, because you just add up the exponents. In the third one, the degree would be 11. So which one has the highest degree? What term?
Y. Oh, x.
The last one. We've got 3 terms here. 1, 2, 3. So the one with the highest degree would be -x to the 7th power times y to the 4th power. The next highest degree would be -2x to the 3rd power, y to the 6th, then plus 4xy. Next page talks about examples that are not polynomials. You have, I think, some questions like this on the homework, if it's a polynomial or not. If you have a square root, this makes it not a polynomial. Also, if you have a negative exponent, this is not a polynomial. So polynomials have to be whole positive numbers. Next page, we're going to be adding polynomials. When we add polynomials, we need to make sure they are like terms, so they have to have the same degree. When we add them together, the degree stays the same. We're just adding the coefficients. So here, I have 5x to the 3rd power and an x to the 3rd power. We add the coefficients. What's the coefficient of the x to the 3rd power, that second one that we have? 1. Awesome. When there's no degree, or when there's no coefficient, right, and it's a 1. So 5 plus 1 would be 6x to the 3rd power. So the degree stays the same. We just add the coefficients. We're adding the number out front. Then we have -7x squared plus 2x squared. What would we get here? -5x squared. Perfect. Do I have any like terms with the x? Nope. So it would just be minus x. And then -3 plus 8 would be what? 5. So plus 5. So when you write your answer, you want to make sure you put it in standard form. You got to start with the highest degree and then just decrease from there. So this is standard form. Awesome. Let's look at B. B, we're subtracting. Got to be careful when you're subtracting. That minus sign gets distributed to everything in the parentheses behind it. So this would be -3x to the 4th power. What happens when we are subtracting a negative number? What does it turn to? It turns into positive. So plus 4x squared and then minus 3x. Now let's combine our like terms. What's our highest degree? X to the 4th power. So I'm going to start with the x to the 4th powers. What's 7x to the 4th power minus 3x to the 4th power? 4x to the 4th power. What's our next highest degree? Bless you. X to the 2nd power. So what is -x to the 2nd power? plus 4x to the second power. 3x to the second power. Then we have negative 4x minus 3x. Negative 7x, perfect. And then plus 2. So this would be our answer, and this is in standard form. It starts with the highest degree and decreases from there. Perfect. Next, we're going to be multiplying with polynomials. So in example 1, since we just have one term out front, this just gets distributed to everything in the parentheses. So we're not foiling here just because that negative 4x is one term. So we just distribute. So what is negative 4x times 3x squared? So we kind of did this perfect. Negative 12, we multiplied the numbers together, and then what's x times x squared? X to the third, awesome. So when we did this in P2, you just add the exponents together. Next, let's distribute it to the next term. Negative 4x times 5x. Negative 20x squared, perfect. And then the third one, what is negative 4x times negative 1? Plus 4x, awesome. Is this in standard form? Yep, starts with the highest degree and then works its way down. So always make sure you leave your answer in standard form. Awesome. What do we have to do for number 2? Foil. So we start by multiplying our first. What is negative 7y times 5? Negative 35y. Then the outsides, what's negative 7y times negative 9y? Plus 63y squared. Awesome. We add the exponents. Then the inside, what's 3 times 5? Plus 15. And then the last, what's 3 times negative 9y? Negative 27y. Is this in standard form? No. What would have to come first?
Combine like terms.
We got to combine like terms. So starting with my highest degree of 63y squared. Do we have any like terms with that? No. So that's just going to go first, 63y squared. Then we have negative 35y minus 27y. Awesome. Negative 62y. So we just combine the coefficients together. Variable part stays the same. And then what's last? Plus 15. Perfect. Is this in standard form now?
Yeah.
Yes. 3 is similar, but in our first parentheses, we've got 2 terms. In the second parentheses, we have 3 terms. So it's a little bit more than just foiling. We have to make sure every term in the first parentheses gets multiplied to everything in the second. So starting with the 3y squared, I'm going to distribute that to everything in the second parentheses. What is 3y squared times 4y to the third power? 12y to what power? To the fifth power, perfect. Add the exponents when multiplying. What's 3y squared times negative 5y squared? Negative 15y to the fourth power. And then what is 3y squared times 9y? Awesome. So plus 27y to the third power. Now we have to do the same thing with the 6. We got to make sure everything in the first parentheses gets multiplied to everything in the second. So with the 6, we have 6 times 4y to the third power. What do we get? Plus 24y to the third power. Then 6 times negative 5y squared. Negative 30y to the second power. And then 6 times 9y. Plus 54y. Awesome. What do we do next? Combine like terms. We got to make sure it's in standard form and combine like terms. So starting with my highest degree, I've got 12y to the fifth power. Do we have anything to combine with that? No. Then we have the fourth power. Do we have anything to combine with that? Nope. So negative 15y to the fourth power. What about y to the third power? Yeah. So what's 27y to the third power plus 24y to the third power? So plus 51y to the third power. Any other like terms? Nope. So we can just write it in standard form. So minus 30y squared plus 54y. Next, we're going to be continuing to multiply. Yeah. Here we have some special products. We've got special rules when there's certain cases that we're multiplying. If you forget your special rules, you can always just FOIL it out. So these are just kind of shortcuts if you want to use them. If you forget what the special rules are, just FOIL it, you'll get the same answer. So if you have conjugates, we talked about conjugates yesterday. Conjugates are when they're the same numbers, but the signs in the middle are different. So we have a u plus v times u minus v. The shortcut to FOIL conjugates is you take the first number squared minus the second number squared. So in the example on the right here, since these are conjugates, they're the same thing but different signs in the middle. We take the first term and square it, so x squared, minus the second number and square it, 4 squared. So x squared is just x squared minus what's 4 squared? 16. So we'd get x squared minus 16. If we FOILed this out, you'd get the same answer. Let's FOIL it. X times x is x squared. X times negative 4, negative 4x. Then we have plus 4x. 4 times negative 4? Minus 16. So our middles cancel. And then we have x squared minus 16. Is that the same answer? Yeah. So if you forget your shortcut, just FOIL it out. It's an extra step when you FOIL, but you'll still get the right answer. When you have a binomial squared, you can use this shortcut. So it's u squared plus, so the first number squared, plus 2 times u times v plus v squared. So this one, honestly, I think it's easier. Write it twice. X plus 3 squared is x plus 3 times x plus 3, and then FOIL. I think this way is easier. Write it twice, FOIL it out. But let's do our shortcut just to practice. So u squared would be the first number squared, plus 2 times x times 3, plus the second number squared, which is 3 squared. So we get x squared plus, in the middle we'd have 6x plus 9. Let's FOIL it out and see if we get the same answer. When we FOIL, we have x times x, which would be x squared. X times 3 plus 3x, 3 times x plus 3x, and 3 times 3 plus 9. Then we combine our like terms, we get x squared plus 6x plus 9. So same thing. It is the same thing, just two different ways of doing it. Personally, I don't like remembering the shortcut for this. First one, shortcut comes in handy. This one's not really that much shorter. Just write it twice and FOIL it out. Any questions here? It's the same thing when you have a minus, but the sign in the middle changes. So when the sign in the middle changes here, if you have u minus v squared, the sign in the middle changes here. We'll practice the shortcut. So we have 3x squared minus 2 times 3x times 2 plus 2 squared. So this is just our shortcut. Just plugging in 3x for u and 2 for v. 3x squared. Be careful here. We're squaring the 3 and squaring the x. What's 3x squared? 9x squared. Awesome. Then here we have negative 2 times 3x. Negative 6x times 2. Negative 12x. Perfect. And then 2 squared is plus 4. Perfect. So this is the shortcut. If you forget the shortcut, write it twice, FOIL it out. We've got 3x minus 2 times 3x minus 2. And FOIL. Yes. Yeah. For the third one, or for the next one, it's u plus v to the third power. These are the shortcuts for it. Again, if you forget the shortcut, write it twice. Write it 3 times though. Here it's the third power, so you write it 3 times and FOIL it out. If I were to write this 3 times, we have x plus 2 times x plus 2 times x plus 2. How would I multiply these 3 things together? What would I have to do first? Awesome. FOIL the first 2, and then just FOIL this third one with it. So get an answer, then multiply the third one to it. So let's FOIL these out. We've got x times x, which would be x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2, 4. When we combine our like terms, we get x squared plus 4x plus 4. Then we want to multiply the third one to it. So then we multiply x plus 2. So here, since you have 3 terms that are getting multiplied by 2, it's a little bit more than FOILing. Just make sure everything in the first parentheses gets multiplied to everything in the second. So starting with x squared. What's x squared times x? X cubed. What's x squared times 2? 2x squared. Then moving on to the next term, we've got 4x. 4x times x? 4x squared. 4x times 2? 8x. And then moving on to 4. 4 times x? 4x. And 4 times 2? 8. What would we do next? Combine like terms. So we've got x to the third power. When we combine our x squareds, what's 2x squared plus 4x squared? 6x squared. What's 8x plus 4x? 12x. And then lastly, plus 8. So multiplying it 3 times is a little bit more work than using the shortcut. But I think memorizing this shortcut is kind of not fun. I would just write it 3 times, FOIL it out. Yes. So in our last example, we have 5x plus 9 times 5x minus 9. What's special about these? They're conjugates. They're the same thing, but the sign in the middle is different. So we can FOIL it, or we could use our shortcut. What do you want to try? Let's try the shortcut. So in our shortcut, we take the first number, or first term, and square it, minus the second term squared. Be careful when you do 5x squared, we got to square the 5 and square the x. So what is 5x squared? 25x squared minus, what's 9 squared? 81. If you want to FOIL this out, see if you get the same answer. You will if you FOIL it out correctly. So when they're conjugates, these are conjugates. I think the conjugate shortcut's easy to remember, but if you don't remember, just FOIL it out. You'll get the same thing. Wait for one of them. Let's say we had 5xy times 3x squared y to the third power minus 2x. We'll go fourth power. No y. There. What would we do to multiply these? Kind of FOILing, but here, since it's just one term on the outside, we're just distributing. So it gets distributed to both terms on the inside. So to multiply 5xy times 3x squared y cubed, remember we multiplied the numbers together, so this would be 15. Then what's x times x squared? X to the third. What's y times y to the third? Y to the fourth. Perfect. Then when we distribute it to the second one, What is 5xy times negative 2x to the fourth power? Negative 10x to what power? To the fifth times y. Perfect. So that would be your answer. So sometimes you may have more than one variable when you're FOILing or when you're distributing. So remember, you're just combining the ones with the common basis.